Good morning, students. Chapter 2, Units and Measurement. Yes, in previous lecture we have discussed about what is physical quantity, unit, fundamental quantities, different system of units, then particularly in SI system, 7 basic quantities, their units, their symbol, then derived quantities, then yes, in last lecture we have discussed about 2 supplementary quantities, that is plane angle and solid angle. Okay, now yes, these are numbers of quantities. Now we will see measurement of some fundamental quantities. Yes, length is first fundamental quantity. So yes, today's topic is measurement of length. Measurement of length. Okay, if I ask you a question, how to find length of this word, then yes, first instrument that is in your mind is scale, with the help of meter scale. With the help of meter scale. Yes or no? Yes, it is. Now, see, each and every instrument have some least count. Now, what is meaning of least count measure? See, least count measure. Least count. Okay, it is also denoted by LC. What is least count? See, if it is scale which is enlarged, okay, it is scale. Here it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and here it is 1. Yes or no? Yes, it is. Yes or no? Yes, it is. Okay, in scale, calibration is like this. Then again, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, and here it is 2. So yes, it is a part of meter scale. It is a part of meter scale. That I think you know. Okay, yes, this distance, it is called 1 centimeter. Again, it is enlarged view of a scale. Okay, so yes, it is 1 centimeter. Now, what is minimum distance? What is minimum distance? What is the smallest distance that this scale can measure? That is distance between two successive threads. And yes, we know that what is distance between these two successive threads? What is distance between these two successive threads? It is 1 mm. It is 1 mm. Yes, between any two threads, what is distance? It is 1 mm. It is 1 mm. Yes or no? Yes, it is. So yes, with the help of scale, minimum distance measured, minimum length measured is 1 mm. You cannot measure length or distance which is less than 1 mm with the help of scale. You cannot measure length which is less than 1 mm with the help of scale. So that 1 mm is called least count of scale. 1 mm is called least count of scale. So yes, what is minimum? What is least count? Least count is smallest measurement taken by instrument. Clear about this? So yes, what is meaning of least count? That you have to remember. Okay, if least count of the scale, yes, what is least count of scale? Least count of meter scale. Least count of meter scale is 1 mm, and 1 mm means 10⁻³ meter. Means the length or distance which is less than 1 mm or less than 10⁻³ meter cannot be measured with the help of meter scale. Clear about this? What is meaning of least count? Yes, if you have watched Okay, then watch, there are three hands, hour hand, minute hand and second hand. So what is minimum measurement taken by that watch? That is 1 second. It is 1 second. It means least count of watch is 1 second. Means you can measure minimum time, that is 1 second. You cannot measure a time less than 1 second with the help of watch. Clear about this? So yes, it is meaning of least count. It is meaning of least count. Okay. Now for measurement of length, first of all we will see some direct methods. First of all we will see some direct methods. Okay. First of all we will see some direct method. Direct method means you have to compare instrument with that object. If I say I want to find length of this line, then yes, you have to put scale like this. You have to put scale like this. So that is direct method. That is direct method. Yes, in direct method, which instruments are used? First, scale. First, scale. Scale, meter scale, which can measure up to distance 10 raised to minus 3 meter. Its least count is 10 raised to minus 3 meter. Its least count is 10 raised to minus 3 meter. Okay, so yes, what is minimum distance measured by meter scale? It is 10 raised to minus 3 meter. But if I want to measure distance length less than 10 raised to minus 3 meter, then how to measure? Yes, there are another instruments. Yes, first one is vernier calipers. Vernier calipers is one instrument. Yes, we will see experiments based on vernier calipers. What is vernier caliper? How to use vernier caliper? How to take readings with the help of vernier capital? That we will see in practical. Right now, you have to remember its least count. That is, its least count is 10 raised to minus 4 meter. Means the length which cannot be measured with the help of scale, we can measure with the help of vernier calipers. Clear about this? For example, if I want to measure diameter of this chalk, I can measure diameter of this chalk with the help of vernier calipers. Okay. Now next one is screw gauge. And spherometer. Its least count is 10 raised to minus 5 meter. Clear about this? So yes, resolution of scale is 10 raised to minus 3 meter of vernier calipers, 10 raised to minus 4 meter of screw gauge, and spherometer it is 10 raised to minus 5 meter. You have to remember this least count. Least count means they can measure up to this small distance. Clear about this? Yes, you know how to take readings with the help of scale. Okay, I will explain in practical how to take readings with the help of vernier calipers, screw gauge and spherometer. Don't worry about it. Okay, right now you have to remember least count for this instrument in direct method. Okay, yes, see, with the help of scale you can measure length of this board. With the help of vernier calipers you can measure diameter of this chalk. With the help of screw gauge you can measure diameter of wire. With the help of screw gauge you can measure thickness of any material. Okay, so yes, these are uses of direct method. But if I say, okay, I want to find distance between Earth and Sun. If I want to find distance between Earth and Moon, then is it possible with the help of scale? Okay, yes, take one scale and yes, I am moving from Earth to Moon, I am moving from Earth to Moon. with the help of scale. Okay, 1, then 2, then 3, then 4. Is it possible to measure distance between Earth and Moon with the help of scale? No, it is not possible. No, it is not possible. Then how to find such very large distance? How to find such very large distance? Okay, yes, this distance is they are measurable with the help of some instruments, and for that we are using direct method. But there are some distances, some very large distances for which we cannot use such direct method, and for them we have to use some indirect method. We have to use some indirect method. And what is that indirect method? See, here it is. Indirect method. Indirect method. And in indirect method, we are taking one particular case, that is to measure large distance. For example, that is distance between Earth and Moon, or other planet. Okay, so yes, indirect method, we are taking one example to measure large distance, that is distance between Earth and Moon or other planet. Okay, distance between Earth and Moon and another planet. Clear about this? Okay, now how to find this distance? See, take care about this method. It is easy method. What to do? Here it is. Suppose it is Earth. Yes, it is Earth. And let here it is Moon or another planet. Okay? Yes. Distance between them. This. It is capital D. Distance between them, it is capital D. It is AB. A for ascent, B for beta, not AB, it is diameter AB. And let it is B. Clear about this? So yes, first of all, here I have to write data. Okay, what is capital D? Capital D is distance between Earth and planet. Distance between Earth and planet. What is small b? Small b is equal to AB and is equal to diameter, and is equal to, it is diameter of Earth. Okay, so yes, this two data you have to remember. Okay, capital D, that is distance between Earth and planet, and small b, that is diameter of Earth. Now, how to take readings? Or how to measure distance? First of all, you have to observe this planet from point A. So yes, if I denote this planet by P, then from this point you have to observe planet, then it is observation line A. Then observe the same planet from diametrically opposite end, that is B. So now it becomes observation line B. Clear about this? You have to observe this planet from two diametrically opposite points on Earth, that is from A and B. So you will get two observation lines, AP and B. See, these two observation lines, or we can say this diameter, subtends some angle theta with planet. Clear about this? Okay. Again, what you have to do? Observe this planet P from point A. It is observation line AP. Then observe planet from diametrically opposite end, that is B. This observation line is BP. These two observation lines make some angle theta. Clear about this? Yes or no? Yes. Okay. So yes, theta theta is angle made by observation lines AP and BP at planet. Clear about this? Okay. Now see, it is distance between Earth and planet. Yes or no? And it is diameter of Earth. We know that. Yes, distance between Earth and planet, it is very long. Yes or no? Large. But diameter of Earth is limited. So here we can say one assumption, that is here capital D is very greater than B. Yes or no? Capital D is very greater than B. Obviously, distance between Earth and planet, it is larger than diameter of Earth. Yes or no? Yes. So in these circumstances, now we have to use one definition that we have discussed in last lecture. That is plane angle. That is plane angle. What is plane angle? Plane angle is equal to, it is arc upon radius. Plane angle is equal to, it is arc upon radius. Okay. It is plane angle is equal to arc upon radius. So how to find with the help of this? See. Now, plane angle is equal to, it is arc upon radius. Now, see here it is. It is angle theta. Okay. Yes, this angle theta is made by this diameter with this planet, which is at distance d. Okay. Now, as here this distance between Earth and planet is very larger than diameter of Earth, we can say that this arc, this diameter and this diameter, they are nearly equal with respect to this distance d. For example, this distance d, it is 10,000. For example, okay, just the numbers. This distance d is 10,000. Yes or no? This AB is 49. This arc is 51. This arc is 51. Yes or no? So with respect to this 10,000, 49, 51 and 51, they are nearly same. Okay. There is no more difference. Clear about this? So yes, here how to use this definition. Here I have to write as a plane angle theta is equal to, as arc I will consider diameter of Earth. Divided by, as radius I will consider distance between Earth and planet. I will consider distance between Earth and planet. Clear about this? Why? Because capital D is very greater than B. Okay. So with respect to this very large distance, these three distance we can take nearly same. Clear about this? So yes, plane angle is equal to arc upon radius. Theta is equal to its diameter of Earth upon distance between Earth and planet. So therefore, theta is equal to what is diameter of Earth? Yes, it is B. Okay. And what is distance between Earth and planet? It is capital D. So if you want to find distance between Earth and planet, then D is equal to, it is B upon. Clear about this? And yes, this method is called parallax method. Okay, this method is called parallax method. So yes, it is one important question. Okay, what is parallax method to measure very large distance, that is distance between Earth and planet, Earth and moon, or Earth and sun? Clear about this? This angle theta is called parallax angle. This angle theta is called parallax angle. It is called parallax angle. Okay. Now what is meaning of parallax? What is meaning of parallax? Okay. If it is one chalk, it is one chalk. Okay. And I am standing in front of wall. First of all, close your right eye and you see that yes, it is chalk with the help of left eye. Then observe the same chalk at same position by closing your left eye with the help of right eye. Then you will see, okay, yes, this chalk is displaced by some amount. Yes or no? This chalk is displaced by some amount. Actually, it is at the same position. But if, first of all, I observe this chalk with the help of left eye and then with the help of right eye. Okay, then yes, you will find that, yes, the position of chalk seems to be changed. Okay, and yes, it is called parallax. It is called parallax. Clear about this? So yes, this indirect method, which is called parallax method, it is used to measure large distance, that is distance between Earth and planet, or Earth and moon, or Earth and sun, or whatever, Earth and Mars. Clear about this? So yes, for 2 marks it is one important question. For 2 marks it is one important question. Okay? Now next, same question is how to measure size of planet. How to measure size of planet. Size of planet means, now what is meaning of size? If I say what is the size of this classroom, then size of classroom means LBH. Obviously it is LBH. What is size of this board? Then it is L and B, only length and width. Yes or no? So size means dimensions. Size means dimensions. What is size of planet? Planet we are taking spherical, sphere. Then what is size of sphere? It is its diameter or its radius. It is its diameter or its radius. So yes, here we have to find diameter of planet. Here we have to find diameter of planet. Okay. So what is method? See, here it is. That it is Earth. Okay, it is planet. It is planet. Clear about this? Okay. Yes. Yes, it is planet. Yes, it is planet. It is P. It is E. That is Earth. Okay. Distance between Earth and planet. It is capital D. Yes, we know how to find distance between Earth and planet. Yes or no? Yes, it is. Now we have to find size of planet. That is left. It is size of planet. It is A. Here it is B. Okay. Let it is B. So again, I have to assume data. Okay, what is capital D? Capital D is distance. Capital D is distance between Earth and planet. Distance between Earth and planet. What is B? Yes, B is diameter. B is diameter of planet. B is diameter of planet. Now here what is method? Here what is method? See, in this case, from a place on earth, first of all you have to observe this point A of planet with the help of instrument. Okay, then from the same point you have to observe its diametrically opposite point. Okay, from the same place on earth, you have to observe point A of planet, and then from the same point observe diametrically opposite point. Clear about this? Clear about this? So see, from this point you have to observe two diametrically opposite points of planet. So see again, this diameter of planet subtends some angle alpha, denote. Okay, this indication we have changed. Okay, this diameter of planet subtends angle alpha with Earth. Clear about this? So what is alpha? Alpha is angle made by diameter of planet at Earth, and it is also called, alpha is also called angular diameter of planet. It is called angular diameter of planet. Clear about this? Because this angle is made by this diameter. See, this angle is made by this diameter of planet. Clear about this? So again, you have to remember these 3 points. What is capital D, what is small d, and what is alpha. Now again, I will use the same definition. That is plane angle. Is equal to, it is arc upon radius. Plane angle is equal to, it is arc upon radius. Okay, again here it is, capital D is very greater than B. Then how to write this? Plane angle means alpha. Yes, here it is alpha. As arc, I will consider diameter of planet. And divided by distance between Earth and planet. Okay, so therefore here alpha is equal to diameter of planet is B divided by distance between Earth and planet, that is capital D. So yes, I have to find diameter of planet, so B is equal to, it is alpha D. So yes, with the help of this equation you can find what is size of planet. Size of planet means you have to find diameter of planet. Clear about this? So yes, it is again parallax method to find or to measure size of planet. Clear about this? So yes, in today's lecture we have discussed about measurement of length. Measurement of length with the help of some direct method and with the help of some indirect method. Okay, how to use say vernier calipers and screw gauge or spirometer, that we will see in practical. It is one indirect method for measurement of very large distance. Now again there are some limitations. There is some limitation for scale, for vernier caliper, for screw gauge. Okay, if I say you that this chalk is made up of particles are made up of molecules are made up of atoms, atom is made up of nucleus. So no, then how to measure size of nucleus? With the help of scale? No. With the help of vernier calipers? No. With the help of screw gauge? No. With the help of spirometer? No. This parallax method? No. We have to use some special methods to find very small size. That we will see in next lecture. For this lecture, this is it.